here we go. And it would really help if I presented my screen. Gotcha. So nice. All right. So this was our solution to our sample problem that we had to go ahead and write. This is month, day, year in terms of what we've got going on. Everything in bold is basically part of our solution. So at the very, very top, import java.util.scanner. I told you that I would provide that for you, but understand that if you were just looking at this code here for the sample assessment, if we miss that statement, it's not going to work at all. We have to understand what the import statement does as far as bringing in this whole scanner class for me to work with. As we said, that our programs are really going to take kind of the same kind of a feel where we declare some variables, we do some input, we do some processing, we do some output. That's really the same kind of general feel that we've got for this whole thing. And basically what we've got going on here, we've got 3 integers being declared. And this is where things get a little bit crazy because you could have called them whatever you want. You could have assigned them anything that you want. You could have realistically just declared them if you wanted to. So when I go ahead and I look at grading this stuff, I have to kind of accommodate for the things that you did, okay? Making sure that it was done, all right, for the right reasons and with the correct syntax. We've got our scanner declared here, so we're going to go ahead and create that. Then we basically have our prompts for each one of these guys. I did mine all as integers. Once again, we're going to basically be going ahead and throwing them out. The order in which you actually prompt for these 3 things really doesn't make any bit of a difference. You could go month, day, year, day, month, whatever you wanted to do, as long as your prompts were actually clear enough so that we could say it. Once again, we're going to be taking all that information in, putting it into our local variables, and then at the end, we're going to go ahead and output that. Can you give me a window? I'm sorry. No, that's perfectly acceptable. I thought I threw one at you guys before. I'm sorry. Yeah, like size 12 font from like 80 feet away is pretty hard to see, so I apologize. So, with this here, kind of take a look-see at this. Once again, there is some opportunity for you to kind of move a couple statements around here, change the names, change the initialization values. I would say you should basically be hanging with an integer data type here. I don't really see much need to go anywhere but an integer. It doesn't make a whole lot of sense. Understanding that when we do output this here, we have not error checked anything. They could say it's the 453rd day of the 23rd month of year 10,000. Yeah, our program would take it, okay? Obviously not being correct, but it would take it. It would go ahead and display it to the screen. All right? Do we have any questions over what we see as a solution? If no, maybe so. Okay. What I do want to do here is draw a quick little picture because what you're seeing on the screen right now is the first half of your assessment. This is going to be the second half of your assessment, okay? So what we're going to do is essentially draw a picture of whatever code you're writing. So you wrote the code, you have the names, you have the stuff. I'm going to draw a picture for my example here, okay? I may have to abbreviate a little bit just to kind of fit it on the screen, but I will do my best. So somewhere, somehow, you're going to need a main. We're going to need some memory here somewhere so that we can go ahead and plow some values into it. And I'm just going to start running this thing. So in year, we're going to go ahead and declare year as a local variable. We're going to stick our 3 nines, negative 999 inside of it. Life is pretty good. Okay, line of code done. Month. And we're going to follow suit with day. Okay, so we get all 3 of these guys out of the way. Life looks pretty good. Now our next statement here, remember this is an important one from an object-oriented programming standpoint as well as all sorts of other things. We want to see here that input is connected. Oops, there's a NN. Oop, almost got it. Okay, so we're going to go ahead and create our scanner object here. Once again, I'm using some terminology that we will continue to use. Input is a variable. It's actually called an object variable because it remembers where an object is. Not necessarily just a block of memory and RAM. This is actually an object that has a whole bunch of stuff in it. We know that there's next int, next double, next boolean, next line inside of here. You do not, I repeat, you do not need to put anything inside of here. If you wish to, well, waste your time. Okay? Perfectly fine. It's one of those things that as we start looking at our objects, there may be 100 different methods in there. There may be all sorts of variable storage in there. There may be all sorts of garbage. We're just going to kind of symbolize it with a box right now. All right. Line of code done. We're good to go. Now we are going to get to our output here. Output in this case here, depending upon what you wrote, should be what's coming out. I'm just going to paraphrase some of this because I don't have nearly enough room, but I want to kind of emphasize what we've got going on. So system out print line happens, and what we're going to have going on here is this idea that your cursor is going to be sitting right here. On your assessment, if you're asking for input, you need to tell me what input you put in, okay? I don't know what you're typing, but whatever you're typing, you need to go ahead and show me that it went into the computer, okay? I chose to enter 2019. If you don't show me that down there in the output, I don't know what you did. I don't know how it's going to affect anything up there, much less how it's going to change your result. Yeah. Oh, just write it. I'll understand it. So, Jack's asking a great question. What's the difference between input and output? Well, I'm going to see what your prompt is right here, so I'll assume that that's the string, and then whatever you have left over, all right, I'm going to give you the benefit of the doubt for anything that I've got, okay? No, I would write out the whole thing. I'm just trying to abbreviate right now just so that we can actually get it all done. I will take it either way. But you are absolutely right. The system out print line would kick it to the next line. Doesn't matter too much to me as long as I can see the information flowing in. Yep. So that 2019, remember that 2019 is actually going to go ahead and get dumped right here, which then gets assigned. So my next statement here, what I'd want to see is that 2019 ends up inside of there. So whatever you decided to type in as input, that's what's going into this thing. So lots of really, really, really good questions here. Okay, and we're just going to kind of finish up the rest of this thing. So we've got a month going on here. Once again, cursor is sitting here. Doesn't really matter what we've got. We want to go ahead and type in a 9. Perfectly acceptable. Remember that 9 is coming in here, going into month. So we're going to go ahead and change this to a 9. And lastly here, we're going to ask what the day is. And once again, you have the ability to specify what your prompt is. Okay, year, month, day, and okay, could be a little nicer. Great question. Should you be drawing the arrows from down here anywhere? Absolutely not. Okay, that is a great question because what's going to happen is if we end up doing that, we're just going to have spaghetti on the screen. Okay, we're just going to have lines all over the place. So when we go ahead and we look at this, folks, these lines are actually connections to different places. So when I see year connected to that memory location, that's actually when I type in year in my program, it's basically a reference to that hunk of memory. It basically says whatever's inside of that thing. When I say input, it says that's where I'm going to be going with this thing. So what I want you to do, you crossing off this number, okay? So if we say 17 right here, and that goes into day, you just showed me that that value came in. You showed me the assignment by actually changing it there. So that's exactly what I want to see, okay? Great questions. You guys have done a phenomenal job all year asking questions of all this stuff. Yep.
Do you not write at the bottom? No, the last one.
We're getting right there right now. So we got one more line of output at the very, very bottom here. So month, add to it a dash, add to a day, and a year. So we're going to go grab all three of those variables here. So in this case here, month that I typed in was a 9. We go to the day, we go to the year, and away we go. So once again, we're not going to be abbreviating anything in our output, but I did just for the sake of actually being able to fit it on the screen. But I've shown you all the input that I have. That input got reflected and changed inside of memory here with my assignment statements. And then we've got our final output at the bottom in terms of what was in those variables. Okay? Pretty good, pretty good, pretty good. All right. Might take 5 minutes. Let this settle on in. We'll go ahead and take assessment. What did I do? All right. So, once again, like I mentioned before, really similar things are happening, with your practice assessments, with the programming opportunities there. I would deem that was actually probably easier than a lot of the things that we've done. You may find that also as a trend as we move forward through some of these problems. For some of the programming opportunities, I will challenge you, okay? And I will probably back off of that for an assessment, okay? So it's not my goal to have you just staring at a piece of paper trying to solve something. So anyhow, let's talk about our next topic here. We're ready to move on. We're ready to get into processing. So we've done declare some variables. We've done our input stuff. We are now ready to do our processing so that we can compute some form of an answer so that we can then eventually display it to the screen. So this is kind of our last missing link piece that we have to put into just kind of the normal general flow to the majority of the programs that we have. We're going to start off kind of nice and easy. We're going to start off in happy land, and we're going to move into not so happy land throughout our discussion here. The programs that I'm going to be asking you to write, we're going to write a lot more of them, by the way, now that we can actually write functional code to kind of actually get a job done here. You're going to see a whole bunch of stuff. All right? So let's talk about a couple of things that we need to just make sure that we know. Assignment operator, variable declaration, all of that is something that we need to know and we need to understand. Ideally, what we're going to be doing is we're going to be doing some math calculations. We're going to be storing those results and then displaying them to the screen. We're going to obviously need an assignment operator to do that. So when you look at this assignment operator here on the right-hand side, the right-hand side is a value. All right? There can be just about anything on the right-hand side, so I can put crazy mathematical expressions there. All of that must get chunked down into one thing before we go ahead and do the assignment operator. So whenever we look at this assignment operator, memory location on the left, value on the right, that is the only way we actually get that value into memory. There may be a ton of work on the right-hand side of that assignment operator that the computer has to evaluate in order to get that answer, okay? Whether it be math, whether it be go get something from the keyboard and bring it back. There could be a lot of work on the right-hand side, but essentially, your assignment operator is very limited in what it can do. It does one thing, take a value on the right, move it into memory on the left. That's all that it does, okay? So, as we go ahead and look at some of the stuff. So, a couple of things here. We're going to need to bounce some ideas of math and Java off of one another here today, because our worlds are very, very similar, and yet they are different. And we need to understand the similarities and the differences here. So as you look at our wonderful order of operations, what stands out as something that's missing? Go back to your PEMDAS days. Exponents, okay? As you look up in this list, we do not have exponents. Why? Because Java does not know how to do exponents. We can teach it how to do exponent, but inherently it's not one of the built-in functions that's part of the math operations for Java. Okay? What else do you see that's a little bit funky in my list? Ethan? Very good. Modular division. Modular division happens to be that percent symbol there. Okay? That is actually a little bit of a funky type of a thing. It's actually going to return the remainder of long division. Now, most of you are probably going, long division, haven't done that in a couple of years. Yep, much less use the remainder for any useful purpose. We're going to get into it. And there are some really neat applications to actually going ahead and grabbing that value. And I've contrived a couple little examples for us to go ahead and deal with. At the end here, it says you may override operations using parentheses. You're going to notice here that we don't use square brackets. Square brackets have a different definition. So like way back when in like, I don't know, 6th grade math where they had parentheses and then they had brackets on the outside of those, we just keep nesting those parentheses together. So however you want to do it, every left parenthesis must have a right parenthesis and so on and so forth, just like a standard math class. But we do not have brackets. Brackets have a completely different meaning inside of this language. All right? So as far as the way that we are going to approach this, I told you we're going to start off nice and easy. We're going to start off in happy, happy, happy land. And that happy land is we are going to look at doing calculations with like data types. We said that Java is a strongly typed language and data types rule the world. And this is going to make Java very happy. You're going to find that the results are very predictable and very expected. Okay? Minus one little thing, but we'll get it. Secondly, once we have this, we are going to have to deal with the unhappy world of unlike data types. This was a question that was brought up with our team lead. What happens when we add a string to an integer? Okay? What happens when we add an integer to a double? What's actually going on inside of my computer? And that's something that we need to understand. Last but not least, we're going to actually show you how to convert between different data types. Now, these are my primitive data types, okay? This is not a string. This is not a scanner. Those are classes, okay, that are doing something completely different. So, as far as this goes, just kind of one little thing here to remember, and I did mention this before, off of some of the fabulous questions that you guys asked. As we're actually doing these calculations, your data type, not only does it govern exactly what you're doing, but it governs how you're doing it. So when we start talking about addition, when we start talking about multiplication and those sorts of things, the actual way the computer is actually doing that binary arithmetic is different. Okay? So we do have to be a little bit careful in what some of our results are. So let's start off in nice happy land. Okay? The plus symbol here. Plus symbol means addition. Addition works from left to right. Order of operations is always going to be preserved. We can override that with parentheses anytime we want. All right, let's get out our big brains here. 7 plus 12 is? All right. What's the difference between the one on the left and the one in the middle? Okay. So when we go ahead and we see this here, what I want us to see is we actually have an integer plus an integer here. 19 as a result. What is that? An integer. Okay. Interesting. 3.5 plus 2.0 plus 8.5. Ooh. Okay. Now, if you are going to do this and you are going to act as the computer, you only do one calculation at a time. Meaning what we're going to do here is we're going to go ahead and boil this down first. So 3.5 plus 2.0. There we go. Okay. All right. 8.5 plus 5.5 is? When we look at this here, we should see that this is a double, this is a double, this is a double. When we add it two doubles together again, we get a double. We add two doubles together again, we should get a double. Okay? So, what we're seeing here, yes, ma'am? We can theoretically no, but the computer can adapt for it. So we're going to deal with mixing our data types in a minute. But what we're trying to hammer home here, guys, is when we are using like data types, with this operation, my like data type is preserved. If I add two integers together, I get an integer. If I add two doubles together, I get a double. Even if it's a 0.0, it is still a double. Okay? So that's something that I want to kind of have in the back of our mind. We can use parentheses also to go ahead and deal with this. Now, on top of this, when we start looking at this, we can go ahead and take the results of any of this stuff and we can store it into memory locations. Now, at this time, we need to make sure that our data types match in order to store information into memory. So if we were looking at this guy from this perspective, here's my wonderful main method. And you should have this vision by now. Our first statement here, we're going to chuck a -999 in there. Line of code done. Age assigned it 10 plus 3. It needs to boil down the 10 plus 3 to a single value, 10 plus 13, excuse me, which is going to be 23. Remember, what we see in the background is we have an integer plus an integer giving me an integer. Can I store an integer into age? Yep, big thumbs up. They're the same data type. Life is good. Now the assignment can be made. 23 ends up inside the box. Okay? Not so bad. Just be careful as you're going ahead and going about this. Once we get through addition, we're going to be burning rubber here. Where's my cursor? There we go. Okay. Now, calculations can be done any which way that you want to. Okay, I can have calculations with just hard-coded numbers inside of my program, as well as I can do calculations with variables if I want to. So if we were going to look at this guy here, got our main method going on here. Whoop, there's an egg. All right, salary. We got a double variable here. Okay, life is good. All right, minimum is going to be declared. There we go. We got another box down here. We're going to assign it at 3.75. All my data types match. Life is pretty good. Now we get down below. We have an assignment statement. Don't care about the assignment until I boil down the right-hand side. The right-hand side, it says the word minimum. That means I am looking for the value of the variable minimum. I need to go over here, grab it out of that box, and what happens here is 3.75 gets dumped down right here. Now we need to go ahead and make sure that we actually evaluate this and add it together. So 3.75 plus 4.25 is?
8.
Thank you. Okay, now that we've got a double, we can go ahead and store it into salary, but once again, do not get stuck in that little 8 versus 8.0. Those are two completely different things in the eyes of Java. Data types rule the world. Okay? One last example here. I'm not going to actually draw this one out, but what we should see, paycheck is going to be assigned salary plus tips. So we're going to go out, grab whatever's in salary, bring it back. Grab whatever's in tips, bring it back, and then we go ahead and we add them together, finally making our assignment. Okay? Questions, problems? You good? All right. What's weird about what you see? Oh, very good. Okay. So we'll start at the top and then we'll work down. So at the very, very top, I love that correction here. We should actually go ahead and assign it a double. If I'm yelling and screaming about data types here, our data types better match. If I declare it as a double, let's assign it a double. All right, as we work down a little bit farther though, we see Bill equals Bill. What do you think? Will it compile? Will it work?
Jack, does it work on does it work on I know.
So, real quick, you should be able to draw a picture of it. If you can draw a picture of it, you should be able to determine whether it's going to work or not. I'll be real quick. First statement done. I'm not going to deal with my output here. I'm not going to actually write it out. You guys can go ahead and do that. Blah, blah, blah. Okay, we get our first two lines of output here, which is good. Bill equals Bill plus 6.5. When I look at that as a computer, I have an assignment operator. The assignment operator says I need a value on the right and a memory location on the left. I have a memory location on the right, but I do not have a value on the left, or excuse me, on the left, but I do not have a value on the right. On the right, I have an expression. That expression must be evaluated down to a value. I don't care where you're putting it. Literally at this point in time, the computer is not looking at the left-hand side of your assignment operator. It says, I need to evaluate this expression. You can put whatever garbage you want over there. It doesn't matter. In this case, Bill, that must be a variable, go grab its value, okay, 0.0, gets dumped down. I don't care where you're putting it. We still have to evaluate this guy out. So 0.0 plus 6.5 is 6.5. Then I can take it and assign it where? Oh, into the variable Bill. All right, 6.5 goes in here. That is good. Same idea here. We got a little more output going on. Now we have another statement. Bill assigned it a value. On the right-hand side is an expression. You must evaluate the expression before you worry about anything else. It doesn't matter where you're putting it. On the right-hand side, go grab the value of Bill, which is 6.5. 6.5 plus 8.25. Uh-oh, that's some tough math.
7.
What do we got? Very good. 14.75 then gets assigned into the variable Bill because that was the location that I put it. At the end here, your final bill is, we're going to grab that 14.75 out of that variable. Yeah, get.
So the computer just knows that the bill on the left side is.
It doesn't worry anything about it. So when it looks at this statement, it says assignment operator, make this a number. Okay? It doesn't care about where you're putting it. Okay? Until it says now it's time to put it into memory, this is where it goes. So whatever crazy calculations you're doing over here, and understand whatever you're doing over here is not going to change anything. Okay? It's just literally pulling stuff out of memory, adding it, subtracting it, doing whatever it's going to do, and then you just stuff it in that memory location.
Does it really matter like what side you added on?
That's a great question. So that does actually make a difference. My assignment operator always works from this side is where my value is, memory location over here. So the adding and everything has to be on the right-hand side to stuff it in the memory location at the left. Okay? Great question. We have a lot of people who screw that up when we go ahead and start writing this code by hand. If you do it in Eclipse, don't worry, it'll blow up at you. It will not like what you're trying to do. Okay? So, lots of really good questions here. This, ladies and gentlemen, is an example of a commonly used thing. I like to call this thing a running total. I'm going to use one variable. I'm going to add stuff to it. 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 Okay? Think about yourself going to the grocery store. You go up to the grocery store, you go up to the cashier, and your bill is 0. Your balance is 0. They scan something, it gets added to the balance. It's added up. Scan the next thing, it gets added to balance. It's added up. There are lots of scenarios that we're going to run into in the programming world where we have this running total kind of a thing where we want to keep track of something that way. Okay? Oh, what else we got here? Doesn't work. The blind, yes. So first of all, we have to determine, does it work? This is inside of a main method. If I hit run, would life be good or bad? Okay, so if that was at the very, very top, good one. Okay. Second question, if all of us ran this program, would we get the same result? No, because everything here is actually based upon this guy right here. Whatever that initial value that you read in off of the keyboard is going to be determined, it's actually going to populate out the rest of the calculations that I have. So understand where we're going with some of this. We're going to be writing programs where we are going to be able to test different input values to get different results. So up until now, we said your programs were completely useless. You could hit run on that thing 1,000,000 times, you would get the same output every single time. Okay? Once we got into input, okay, now we get the same thing echoed every single time. Now we're going to be doing some calculations, which could really change things around. All right, have we killed addition? Yes, we killed addition. Subtraction. What do you think about subtraction? Okay, subtraction really is adding the negative, okay? So when we look at subtraction here, we're going to see the same thing. We have an integer minus an integer. 7 minus 12 is? -5. Is -5 an integer? Yes, it is, okay? By the same token here, we can do all the rest of these examples here. If we would happen to have a double minus a double, which is the first portion of this, we should end up with a double. Likewise, over on the right-hand side, we would have to do the 3 minus 6 first, and then we would have to deal with the other subtractions. Subtraction works exactly the same way addition works. So when we go ahead and we look at this, I wrote up literally the same examples, except for I changed the addition sign to subtraction. We should be able to handle this right now, making this adaptation. Over here, what we really are looking at, we have an integer minus an integer. We have to boil this down to one single value. My data types match, so whatever we've got will work. Life will be good. If we go ahead and we start storing things into different variables, life is still good, but it's really all based upon I have a double minus a double. Go grab the value, throw it in there. I'm going to result this thing into a double, which I'm going to store into a double. All my data types match. Life is glorious. Everything will work. I can store it in 2 different variables if I want to. Okay? By the same thing, I can also have a running total that goes down instead of up. So as we see this here, we should be comfortable with this assignment statement. We need to understand it can only have one value on the right assigned to a memory location on the left. All right. And we did one with age as well.
Yay!
Multiplication. 7 times 3 is?
24.
Okay, what do we really care about? We care about this. In times an int. By the way, your multiplication sign is not the x. Please do not put that there. Please do not write that on an assessment. Your multiplication sign is not a dot. That symbol does not exist on your keyboard. You cannot type it. And it also looks a whole lot like a decimal point when you go ahead and write it on paper. Give me a little asterisk, okay? When we see this here, we really see an integer times an integer, which results in an integer. What about the middle one? Good. Order of operations is going to happen first. We have to go ahead and do these guys. Regardless if we know this off the top of our head, a double times a double is going to be a double. As far as this goes, we will not lose any math in this whole process. Even with our parentheses here, life is going to be great. Our data types are preserved. Okay? There's only one thing I really have to worry about. There is a possibility of something bad happening with both of these. Actually, there was a possibility of both of the previous ones too. An integer times an integer, okay, 99.9% of the time will result in an integer. In Mathland, it will always result in an integer. But there's a limitation inside of Java. Okay? Good. The number limits of the data type. All right? If you took 2 billion on the left times 2 billion on the right, you have just greatly exceeded the capacity of an integer. Now the computer says, you took an integer times an integer, I'm going to give you an integer. It's going to be all messed up. Okay? And Java's a little bit nicer than other languages. C++ and other languages, they will really trash up your program. Okay? So as we start doing these calculations, we always want to think, even this, a double times a double, you can put large enough values in there to exceed that limit or go off the limit the other direction. Okay? But all three of our operations here work identical. Once again, doesn't make a difference if we're hard coding numbers into this thing. Doesn't make a difference if we've got variables intertwined. Our explanation is exactly the same for all three of these operators. All right? We can do running totals as well. Not that big of a deal. Okay? How do we feel? All right, let's see if we can write a quick program or two. What I'd like you to do, grab Eclipse. I would probably create a brand new package for yourself, call it Math Operator, so you've got a nice little collection of what you need. And what we're going to do here is just simply ask you to write a program that prompts the user for their age, displays how old they will be in 7 years of math. Sure. Remember, Control Shift F, auto format. Make your program look pretty.
I really do. I would recommend you not to. It's fine.
Honestly, Google Drive. Google is my. It's Google Drive. I don't know right now. I just have the outline.
I don't really care about it. Stop cutting that off. Someone go in, you turn it on right now. Yeah. I will blow up. Wait. Blow up. I well, you can show this thing. Yes. Yes. It's so much easier. All right.
Did we learn C# in this
What
class?
about Alex? What about
All right. So, if this is me, in my estimation, we should be extremely close, if not done, with the ability to copy and paste off of your other program. Okay. You've got your team there, making sure that it works. So let's just talk about our solution here real quick. Kind of talk about where we're going to go. Oops. Okay. So, in this case, we have a couple different solutions. We have the ability to go ahead and, in this case here, I declared age as well as future. We needed our input here. We need a little prompt. We got our input and stuffed it into age, and then I took age plus 7 and I stored it in a brand new variable. Now, once again, this is stylistically one way to get the problem done. Yes, we could. So, here's the deal. When we start talking about what is the best way of getting this done, your number one answer is whichever way makes sense to you that works. That is your first answer. We do have different ways, different things. Our other solution here, we could have gone ahead, dumped it into H, and added 7 to it. Okay? Any which way that you want to go about this is perfectly acceptable. Okay? So, game plan here, we're basically done for today. I am going to take a look at those assessments. I might have a chance tonight. I don't know. My schedule's pretty full tonight. I have a meeting right after school, so it depends upon how late that meeting goes. If I will be able to get those back in your hands tomorrow. I should be able to enter the grade in as one number this time.
I really appreciate that.
All right, tomorrow, get ready. We are hitting math operators. We are writing code, and we are doing it quickly. Okay?
No.
You want a final already?
Wait, no.
Technically, I actually don't give a midterm or a final.